Greetings and welcome everybody to the 4th Annual Interstellar Probe Exploration Workshop. We have 58 participants already today, and I believe over 200 people have signed up for the event this week, and we are really pleased that you've come back. For those of you who've joined us before, and I want a special welcome to all those who've not been a part of one of our events so far. My name is Michael Paul. I am the study manager for the Pragmatic Interstellar Probe Mission Study. And I'm going to give you a quick overview of where we've been, what we're going to be doing this week, and a little bit of a preview of what we expect over the next couple of years as the Solar and Space Physics Decadal Survey kicks off. And at the end of this first half hour, Andrea Harmon is going to give a demonstration of GatherTown, the place where we have some online networking, if you will, that we'll be doing later in the week for those of you who haven't used GatherTown before. I just want to say that so far, Interstellar Probe has been a very satisfying project to have worked on, and I'm just sorry that we couldn't all do that in person this year. This workshop has been a lot of fun in the past, and I know that it'll still be fun this year as well, and I just miss seeing all of you. So with that, let's take a look at where we've been over the last few years. We started in 2018 at COSPAR in Pasadena, and we were very pleased to receive the funding from NASA to put this study in gear and started out in the right way with an international request for folks to come and join us, to understand what we were doing, to work with us to craft this mission concept, which is going to take more than the resources of just one organization to make happen in the end. And we are really pleased that we were able to start that way. We held 2 workshops in New York City that were relatively small, but very, very productive and very important in terms of building some of those bridges. And we're really glad that we were able to do that, because when fall of 2020 came around for the workshop, for the 3rd workshop, of course, we did that virtually. And I believe that the in-person ties that began to build this team really helped us to make last year's workshop a success. And today, so far, we have 63 participants, and I'm really pleased to see that we're still climbing. Excellent. And in between all of those events, of course, over the last few years, we've been at AGU, the fall meeting, IAC, where we will be again this coming October, EPSC, Big Sky, and many, many more conferences. We really believe that this community effort is what makes the idea worth pursuing. It's the science that comes from the collective ideas of all of you to build up a program, an idea, a mission that really hits the high points of what it would mean to do a mission like this, and why it's important to do, and why it's important to do now. So looking forward this week, Monday, we're going to provide a study results summary. You're going to hear from Ralph McNutt, from Pontus Brandt, from Jim Kinnison about the study report, which is in production right now. We should be releasing it before the end of November to the public, and highlighting a lot of that at the AGU fall session. We have a student program this afternoon. We're really pleased to have many students from around the world signed up to hear more about what it takes to go from an idea through studies, through collaborations, and bring them to fruition as a mission. Tomorrow, you're going to hear a lot about the baseline science mission, about the measurements, and about a payload that could be used to satisfy those requirements. On Wednesday, we're going to dig in even deeper to the science and the instruments, and we're going to talk a lot about the augmented science mission, which takes and builds this mission into an idea that incorporates heliophysics and planetary science in a way that we find very compelling, and we hope you're interested in this aspect of the study as well. Then on Thursday, we're going to talk about building the mission, about the engineering that goes into making this idea become a reality. And you'll hear there a lot about how pragmatic this idea is. Yes, this is an exciting mission. Yes, this is an ambitious mission. Yes, there are risks aplenty when it comes to building any space mission. And one with the timeline that this mission incurs, 50 years, of course, those risks take on a different aspect. But we've focused on pragmatic, and over again in those presentations, you'll be able to see the elements of, yes, this is something that we can say yes to. Yes, this is something that we can build. And yes, this is something that we can look forward to in the future. And you're also going to hear about mission architecture options. We worked hard to figure out what is the most basic way for us to build up a lot of speed and be able to reach the edge of the heliosphere, to get through the heliopause and the heliosheath and out into the pristine interstellar medium as fast as we can, and what are the pragmatic and practical ways to do that in the decades that come. And so that's going to be a very key part of this whole discussion on Thursday, forgive me. And then on Friday, we're going to talk about what it's going to take programmatically to realize Interstellar Probe, and look at a little bit of what our cost estimation has begun to reveal, some other pragmatic aspects of managing and building a mission like this that will go on for many, many decades. And then talk a little bit about what comes next, again, as the Solar and Space Physics Decadal Survey kicks off. All right, and then I want to point out that across the whole week, we have a series of special guests who are going to be speaking as well. Fran Bagenal is joining us this afternoon. Tomorrow we have Merav Alfer. Fran is, of course, from UC Boulder and the New Horizons program, which is now an outer heliosphere mission itself, taking data out way far beyond Pluto, having flown since 2006 when it launched. It's quite exciting to be tracking how that mission's going. And then tomorrow we have Merav Alfer from Boston University, who joined us at our first workshop and has been a collaborator all along the way, talking about modeling the heliosphere. Wednesday, we have Stella Alker from Cornell University joining us. She's a lead author on a recent paper published about some new analysis of Voyager data. It's really exciting to have her join us. And another long collaborator as well on Wednesday, Janet Vertesi, will be speaking. She's a sociologist from Princeton University who has helped us to see what we're doing from a new perspective year after year as we've gone through this study, trying to really build up an idea of what it's going to take to build a culture and a community and a program that can withstand the decades, and to plan it in advance, as opposed to having to deal with looking back and saying, well, wait a minute, we want to keep this going and keep it going and try to patch together a program as the decades go on. But really, what can we do to make this a world-class mission and plan that from the beginning? On Thursday, we're going to hear from two very key collaborators within the NASA community itself, within NASA's own agency itself. Rob Stoke from NASA Marshall Space Flight Center has been a fantastic collaborator from the beginning, helping us understand what can be done with a super heavy lift launch vehicle, what can be done with the Space Launch System to enable this mission. And June Zakrajsek from NASA Glenn Research Center. She's the head of the Radioisotope Power System Office. She'll be talking to us about one of the other key enabling technologies in this, plutonium-powered electricity to run the spacecraft, absolutely essential to the mission. And then on Friday, we're going to hear from Susie Dodd, who is at JPL. She is not only the program manager for Voyager, our flagship, if you will, interstellar mission at the moment, but also she's the head of the Deep Space Network. And so it's great to have her here sharing with us about the current, Vanguard interstellar mission, Voyager 1 and Voyager 2, but also one of the other key pieces of technology necessary to make a mission like this work, the Deep Space Network. And so that'll be on Friday. So looking down the road a little bit, the Space and Solar Physics Decadal Survey, as you're going to hear through a couple of talks this week, is supposed to start in the winter of 2022. White papers are being collected and written now, and Elena Pravonakova is going to talk about that later in the week. As the Decadal Survey kicks off and begins, and the committees start forming up, we do hope that you'll be writing papers about what you believe a mission like this might entail as from the science perspective, as well as if perhaps you'll be on a committee itself. And we're grateful that if you end up on a committee, that you've been able to hear what we've done and understand where this may fit in the grand scheme of things. We hope that you stay connected over the next couple of years as the Decadal Survey goes on. Interstellarprobe.jhupapl.edu is going to be up and running throughout, and all of these materials from today, past workshops, past studies, the many papers that this team has written through the years will be available there. And you can always reach out to us through the website if you lose our emails in the process. And you can stay engaged with us as AGU comes around every year. I believe I know Elena Provornikova is actually going to be chairing the AGU session for interstellar science this year. As I said, we'll be at IAC this fall, and we'll certainly be submitting papers and possibly special sessions to IAC over the next couple of years. And there'll be other community conferences, events, and so forth. Look for us wherever you find yourself. And with that, I want to welcome you again. Come and go as you will this week. We've built in breaks to the schedule so that people can take a moment to stand up, to stretch, to keep the blood flowing. Zoom conferences are certainly a challenge. I know that they're a challenge. You know that they're a challenge. We want to make sure that we can all get through this in good health, in good form, and welcome again.